First thing I want to do in this is clarify some things about the shell method that might not have been clear. So if we have two functions and we're rotating about the y-axis, that's what this little arrow right here means, is that we're rotating about the y-axis, then that means that our shells, our rectangles, are being drawn parallel to the y-axis. And so we're dealing with the height of our shell being the difference between the top and the bottom functions. So that's the first thing. The formula is 2 pi times the integral from a to b, those are the places where they intersect, of the radius of the shell times the height of the shell dx. So when we look at this picture in particular, the radius of my shell goes from the axis I'm revolving around out to my shell. And that distance is whatever the x value is right here. So in this case, for radius, we have x. And for the height, it's this y value up at the top minus this y value. So it's the value of the function at the top function, the value at x of the function on the top minus the function on the bottom. So my height of the shell is going to be f of x minus g of x, whatever that value of x is. Volume equals 2 pi times the integral from a to b of x times f of x minus g of x, and then I forgot the dx at the end. dx at the end. Okay, so that is how we find any volume using the shell method revolving around the y-axis. So let's do an example. Okay, so our first example is the curve y equals sine x squared, and we're going to find the volume of the solid of revolution revolved around the y-axis. So our formula says volume equals 2 pi times the integral from, in this case we're going from 0 to square root of pi, of our radius, which is x, times the value of the top curve at x, which is sine of x squared, minus the value of the bottom curve at x, which is 0, y equals 0, because the bottom curve is our axis, dx. Okay, now we're going to integrate this, and the reason I chose this example is because it's not an easy integration. We have to use substitution, so we have to let u be x squared, and then remember, for substitution you find du, which is just 2x dx. But since what we have in our integral is x and dx, then we need only to have x dx here because we have to know what to substitute. So we're going to move the 2 over to the other side, so we get 1/2 du equals x dx. So now we're going to do our substitution. Now mind you, our bounds from 0 to square root of pi are on x, but I'm going to go ahead and leave the bounds the way they are, and we will change it back to x before we evaluate. So that's 0 to 2 to square root of pi, and we have sine of u, and then we're replacing x dx with 1/2 du, so 1/2 goes here, du goes here, and now we have an easy to integrate function. So we can take the 1/2 and kind of bring it out here, which makes this pi, and we get the integral from 0 to the square root of pi. Again, those are the values of x, of sine u du. So now we're going to integrate. Well, the integral of sine is just negative cosine. So it's negative cosine u from x equals 0 to square root of pi. And then we're going to replace u with what we started with, so we're going to put back x squared. So we get pi times negative cosine of x squared from 0 to square root of pi. And now we have to evaluate that. So we have pi on the outside still of negative cosine of the square root of pi squared minus negative cosine of 0 so that's pi times negative cosine of pi minus negative, so plus cosine of 0. Okay, so the cosine of pi is -1, so we get negative negative 1, plus cosine of 0, which is 1. So that gives us 2 pi as the value of our integral. Okay, our next example is rotating about something other than the y-axis, but still vertical line. So in this case, we have a little bit of different situation. Our shell radius, notice, goes all the way from my line that I'm rotating about, which is x equal -4 right here. This is an example of rotating a shell about something other than the x-axis or the y-axis, but it is a vertical line. So our radius in this case is a little bit different. It goes from my line all the way out to my x. So since the distance from the axis to x is x, and the distance from the line to the axis is 4, my shell radius in this situation is x plus 4. So that's what we start with. then from there on it's pretty similar to the others. So our volume is equal to 2 pi times the integral from 0 to 1 of x plus 4, which is our radius, times the square root of x, which is the top curve, minus x, which is the bottom curve, dx. And now I have to integrate this. To integrate it, we need to do a couple of things. We're going to change this to x to the 1/2 minus x. And then we're going to have to multiply it by x plus 4. So we're going to do some distributing. So we end up with x to the 3/2 minus x squared plus 4x to the 1/2 minus 4x. And then we're going to take the integral of that dx from 0 to 1. So we'll finish writing all the rest of our stuff out. So now let's integrate. Just shift this up a little bit. So we equal 2 pi x to the 3/2 becomes x to the 5/2 because we add 1. And then we multiply by the reciprocal. So that's 2/5. It's the same as dividing by the exponent. Minus x cubed. So we put a 1/3 in front of that to take care of that. Plus x to the 3/2. Now we have to multiply by 2/3. We already have a 4, so it's 8/3. And then minus 2x squared, because when we take the derivative of 2x squared, we get 4x. And we have to evaluate that from 0 to 1. Luckily, we only have to evaluate it at 1, because 0 makes everything 0. So 2 pi times 2/5 times 1 to the 5/2, which is just 1, minus 1/3 times 1 cubed, plus 8/3 times 1 to the 3/2, minus 2 times 1 squared. Like I said, lucky for us, we're only doing 2/5 minus 1/3 plus 8/3 minus 2, which gives us 7/3. So if we do this, we get 2 pi. They all need to be 15ths. So it's going to be 6/15 minus 5/15 plus 40/15 minus 30/15. Multiply this one times 3, that one times 5, that one times 5, and that one times 15. So we end up with 6 minus 5 is 1, plus 40 is 41, minus 30 is 11. So we get 2 pi times 11/15, which comes out to 22 pi over 15. And that's our answer. Okay, our last example is going to be rotating about a horizontal line that's not the x-axis. And you can generalize this or specify it to the x-axis by making the modification of making y equals 0 your revolving axis. It's just going to change your radius. So looking at this picture, I've already got the height marked, but one thing we need to realize about the height is that this is the right curve, and it would be the equivalent of being the top curve when you're going top to bottom, and this is the left curve. So instead of looking at it from top minus bottom, it's going to be right minus left. So the other thing we have to do is our top function is y equals square root of x, and our bottom function is y equal x. But both of these have to be in terms of x equal a y because they're f of y's. So the nice thing is that both of these convert really easily. Y equals square root of x just goes to x equal y squared because you square both sides, and y equal x is already done. It's just x equals y, we switch it. Okay, now the other change is our shell radius. And our shell radius here goes from the location of our rectangle, which is y, and it goes down to our line or up to our line, which in this case is y equal -3. So the distance from the rectangle to the axis is y, and then the distance from the axis to our line is 3. So our shell radius in this case is y plus 3. And our shell height is the curve on the right, which is our y equal x, minus the curve on the left, which is our y squared curve. So now let's write down our integral. The volume is equal to 2 pi times the integral from 0 to 1, and that's our interval on the y-axis, of my shell radius, y plus 3, times my shell height, which is y minus y squared, dy. And then we just have to integrate this lovely thing. So again, we have to distribute. We get 2 pi, the integral from 0 to 1. Y times y gives me y squared. Y times y squared gives me minus y cubed, plus 3y minus 3y squared. So we can combine a couple of terms before we integrate if we want to. I think it'll make it easier. So 2 pi times the integral from 0 to 1 of y squared minus 3y squared is negative 2y squared, minus y cubed plus 3y dy. So now we need to integrate. So 2 pi stays on the outside. Y squared becomes y cubed, and then we have to divide by 3. So it becomes negative 2/3 y cubed, minus y to the 4th. We have to divide by 4, so that gives us 1/4 in front. And then plus y squared. We have to divide by 2, so we end up with 3 halves in front of that. So from 0 to 1. Now we're going to evaluate, and because each of these has a y, we don't have to evaluate at 0 because it becomes 0. So it'll be 2 pi times negative 2/3 times 1 cubed minus 1/4 times 1 to the 4th. That's a 4. Plus 3 halves times 1 squared. So we get 2 pi times negative 2/3 minus 1/4 plus 3 halves all of these need a 12 on the bottom. So 3 times 4 is 12, so that's negative 8, minus 4 times 3 is 12, so that's 3 12s, plus this is to multiply with 6, which gives me 18 12s, all still times 2 pi. So we get 2 pi times negative 8 minus 3 is negative 11, plus 18 is 7 over 12, which gives us 14 pi over 12, which then reduces to 7 pi over 6. So there is our final answer.